Hello Biology 230, this is Dr. Griffin again. This is video 2 out of 4 for Unit 5, which is based on cellular respiration. And again, that's Chapter 9 in your Campbell textbook / e-book. So let's get started. Now last time we introduced the major steps of cellular respiration. Well, the key to respiration in our cells is electron transfer. That is, the transfer of electrons is the main basis for how our cells are able to respire. During chemical reactions that catabolize food, in this case, as you'll see soon, mainly sugar, into molecules that can produce energy, electrons must be transferred. These chemical reactions, which electrons are transferred from one reactant to another, are known as redox reactions. Redox reactions are simply reactions where reduction and oxidation take place, and therefore you have redox reactions. Redox reactions, the reactants, so seen here, A and B are our reactants here on the left side of our chemical equation, are either reduced or oxidized. Well, what does that mean? Reduction takes place when a reactant gains electrons. This is reducing the positive charge of an atom, and so therefore that's why this term is called reduction. So let's just focus on that just for 1 minute. Reduction, gaining electrons, reducing positive charge. Oxidation is the converse. This is where a reactant will lose a set of electrons or electrons. So therefore oxidation is gaining positive charge, and so we say they are being oxidized. In this formula here seen at the bottom of the PowerPoint slide, get my mouse to show up, thank you. Compound A or reactant A gets oxidized. You can see here it starts off with 2 electrons denoted by the E superscript negative sign. Compound A gets oxidized during this equation, during this chemical reaction, and thus it only has 1 electron. It loses an electric charge. It loses a negative charge. Therefore, compound A gets oxidized. A good way to remember this is the word oil. Oxidation is losing an electron. On the opposite, compound B gets reduced. You see, it starts off neutral, no positive or negative charge at all. When the reaction occurs, compound B, now the product over here, is reduced. It now has 1 electron, electric charge. Therefore, B gets reduced. And another way to remember this is the word rig. Reduction is gaining electrons. So oxidation, you are losing the electrons. Reduction, you are gaining electrons. And these redox reactions occur all over in the 3 major steps of cellular respiration. During redox reactions, reactants oxidize or reduce each other. You can see here A, which is oxidized because it loses an electron. We refer to that as A gets oxidized by B because B is accepting the electron from A. Does everyone see that? A starts off with 2 electrons, ends up with 1. The 1 that it lost ends up on compound B. Therefore, A gets oxidized by B, and compound B is known as the oxidizing agent because it takes electron from A. Now compound A is known as the reducing agent because it donates electrons to B, compound B. Again, A starts off with 2 electrons and gives 1 to compound B. B gets reduced by compound A. I hope that makes sense. If not, go through this multiple times and see if you can quickly identify which compound is oxidized or reduced, and which compound is the reducing agent, and which compound is the oxidizing agent. The compound that gets oxidized is most likely going to be the reducing agent, because as it loses an electron, oxidation, it will donate that electron to the other compound, such as A here loses an electron and donates that electron to compound B. Thus A is the reducing agent. There's plenty of questions in your book in chapter 9, and I will suggest and give you more questions in class when I or Dr. Bradford or Dr. Whittington see you in our investigations course associated with this class. But that's it for this video, and this is the end of video 2 out of 4 for module 5. Don't forget to view and learn from the next video. I'll see you soon. This is Dr. Griffin at Tuskegee University.